Healthcare facilities present a unique challenge to the construction industry. Sick patients often have compromised immune systems, and keeping the environment free from dust and debris that can cause infection must always be the top priority. Infection control risk assessment, or ICRA plans, may vary, so it is important to become familiar with each facility's guidelines before construction begins. The keys to dust control on these job sites are barriers, negative air pressure, and housekeeping. Erecting barriers helps contain dust for infection control and also helps keep the debris, noise, and vibration from affecting the patients, visitors, and healthcare staff outside of your work area. Setting up and breaking down a barrier could take more time than actually doing the required construction work. And while it may be tempting to take shortcuts to improve efficiency, you must always remember that the first priority is to avoid harming people with your construction activities. How a barrier is constructed differs depending on how long it needs to be in place. For quick jobs, the materials might be as simple as plastic sheeting and a roll of tape. On jobs that require more time, metal studs and drywall can be used to build a long-term barrier. A mobile containment cube is one of the options available for short-term jobs. A mobile containment cube, or pop-up enclosure, is a plastic enclosure with extension poles that is mounted onto a rolling platform. This type of barrier is designed to use a small negative air machine with a HEPA filter to manage dust. A mobile containment cube would be a good choice for work above a drop ceiling, such as removing ceiling tiles for inspection, running cables, or doing HVAC work. The cube's rolling platform is small enough to fit through doorways and into elevators, but still large enough to hold a 6-foot or 8-foot ladder inside its walls. They usually have zipper doors on several sides, including the top, so that the laborer can gain access to the work area. To use a mobile containment cube, roll it into position and lock the wheels. Unzip the door and climb inside. Next, extend the corner poles until the top frame is pressing against the ceiling. With some models, you have the option to lift the enclosure off of the wheeled platform and place it directly on the floor. With the frame extended against the ceiling, put your ladder and tools inside the enclosure. Containment cubes usually include 1 or 2 ports, or tube-shaped openings near the base of the enclosure, to attach a negative air machine or route a HEPA vacuum hose into the cube. Place the negative air machine on the wheeled platform or the floor and attach the port duct to the machine's air inlet. Then secure the port duct with tape, zip ties, or a large hose clamp to prevent any dust from escaping. If the cube is fitted with zippered openings on the sides, it can also be butted up against a wall to do cavity work. Fold the cube's flaps inward and tape them to the wall from inside the cube to make sure that any dust remains inside and does not fall outside onto the floor. Mobile containment cubes are an ideal choice when working in small areas that involve ceiling tiles or wall cavities. They are a valuable tool to help prevent construction-related dust and debris from contaminating medical facilities and patients. To enclose larger areas, walls of plastic sheeting can be used. Plastic film for this purpose is usually 6 or 8 mil thick. It must be treated with anti-static and flame-retardant coatings, and it must have at least 1 hour fire resistance rating. It usually comes in rolls that are 12 feet wide or tall by 100 feet long. Plastic sheeting walls can only be used as a temporary barrier for up to 1 8-hour work shift. The Joint Commission guidelines for hospital construction also state that if a plastic sheeting barrier is used to temporarily replace a permanent firewall, it cannot substitute for that rated wall for more than 8 hours. The quickest way to put up plastic sheeting walls is to use an extension pole system, such as zip wall. Extension pole systems like this are efficient and easy to use. First, unroll the plastic sheeting and cut it to the length you will need. Next, attach the plastic sheeting to the head plate of the first extension pole. Then raise the pole to the ceiling and lock it. Working from one end of the barrier to the other, place the poles about 6 feet apart, pulling the plastic tight across the ceiling as you position each pole. Install all of the poles first, then tuck the plastic sheeting under the feet of the poles toward the inside of the enclosure, again working from one end to the other. Use a wide tape, such as blue painter's tape or polyethylene tape, to seal the edges of the plastic sheeting against the ceiling, walls, and floor. Fold the edges of the plastic sheeting inward toward the inside of the barrier. Then tape the plastic down from outside the barrier. Some hospital ICRA plans might refer to duct tape. However, duct tape can peel off paint or wall coverings and leave a sticky residue when you remove it. Painter's tape or polyethylene tape is the better choice. If you need a stronger seal, put a layer of painter's tape on the wall, floor, or ceiling first. Then stick duct tape or polyethylene tape to the painter's tape. Another option is special double-sided tape for plastic sheeting that has a gentle adhesive on the wall side, but a strong one on the plastic sheeting side. Some extension pole systems use accessories, such as foam-padded rails, to seal the edges of the plastic sheeting against the ceiling, walls, and floor, eliminating the need for tape. The foam rails attach to spring-loaded extension poles that press the plastic tightly against the ceiling and floor. Side clamps attach foam rails vertically to the poles and press the ends of the plastic sheeting tightly against the wall. Plastic sheeting should never be hung from sprinkler pipes, electrical conduits, or mechanical systems. Poly-hanger clips should not be used to attach plastic sheeting to suspended ceiling grids. These clips aren't suitable for a negative air pressure barrier because they poke holes in the plastic sheeting. The ICRA plan may allow a simple flap door in your plastic sheeting wall. Cut a vertical slit for the door opening, and then use double-sided tape to attach a rectangular sheet of plastic above the top of the slit as a door. Use the double-sided tape to wrap up a piece of small-diameter PVC pipe to weigh down the bottom edge of the door flap. It's a good idea to use tape to make eye-level arrows pointing at each edge of the flap door, so it is easy to spot the location of the flap. The plan might specify a 2-foot overlap on each side of the slit opening. The overlap decreases the chances of dust particles escaping. But a zipper door would still be better. It provides a tighter air seal than a flap door. When working with zipper doors, be sure to correctly position, install, and reinforce the door, or it could tear loose. To install a zipper door, check the positioning of the self-adhesive zipper on the plastic sheeting. Make sure the zipper pull is down at the floor, and that the zipper will end below where the plastic sheeting bends at the floor. Before you stick on the zipper, reinforce the plastic sheeting with a vertical strip of tape right where the zipper will go. Peel off the adhesive backing and press the zipper firmly onto the sheeting, centered over the tape. Then reinforce both edges of the zipper with more strips of tape. Unzip it to the top and use a utility knife to cut a slit in the plastic and tape. Make 2 cuts close to the zipper teeth on each side and remove a strip of plastic and tape from the center of the zipper. If you only cut one slit down the middle, the remaining flaps of plastic can catch in the zipper, jamming it. Some zipper kits come with a double-cut razor blade tool that cuts out a wide center strip with one pass. Or you can tape 2 utility knives together to make a double-cut zipper tool. As people go in and out of narrow single-zipper doors, they can tear the plastic or pull up the tape where the plastic is taped to the floor. A solution to that problem, if the facility will allow it, is to make horizontal cuts at the bottom of the door for flaps on one or both sides of the zipper. Then your door opening becomes a wider triangle, not just a narrow vertical slit. First, reinforce the plastic with tape. Then make horizontal cuts about 3 inches above the floor. This leaves a 3-inch lip at the doorway to help keep dust inside the barrier. You can lengthen the slits later if needed. The open slits at the bottom of the door will compromise the containment barrier, but the facility may consider that opening a vent for makeup air. Or you could use plastic sheeting and tape to attach short flaps that cover the slits when the zipper door is closed. Another good practice is to use tape to make a bigger zipper pull, so people can easily open and close the zipper, even while wearing gloves. If a wider opening is needed for carts or materials, use 2 vertical zippers several feet apart to make a rectangular roll-up door. You can use tape to make ties to temporarily hold up a roll-up door. After the negative air machine is running inside the plastic sheeting barrier wall, you may discover that strong negative air pressure is pulling apart the barrier or pulling the tape loose. In that case, it may be necessary to cut a vent opening in the plastic sheeting. Start with a small vent hole first and cover it with filter fabric. It can be enlarged later if needed. The ICRA plan for your work area may require an anteroom. This is a term used in architecture to describe an outer room, such as a waiting area, that opens into another room. As an infection control precaution in healthcare construction, an anteroom is a small separate barrier room at the entrance to your work area, with doors at each end. An anteroom is like the airlock in a spaceship, keeping out the vacuum of space. But in this case, it's keeping in the negative air pressure and the construction dust. Laborers pass through it to go into the work area, and then again to go back out into the public area of the hospital. When you build an anteroom outside your main barrier, think about how big you'll need to make it. The size of your anteroom depends on how it will be used. If the anteroom is mostly to help keep negative air pressure in the main work area and contains sticky mats, it doesn't have to be big. But remember that equipment, carts, and trash gondolas must also pass through the anteroom and its doors. If workers need to change in and out of PPE, such as disposable coveralls and boot covers in the anteroom, then more space will be needed. Regardless of size, if rigid doors are used instead of zipper openings, both doors will need to swing inward and have automatic closers. And the anteroom will also need its own small negative air machine to create and maintain negative air pressure. It is possible to purchase pre-made anteroom modules with aluminum pole frames, similar to mobile containment cubes, with 2 zippered doors on opposite ends. They have extra fabric flaps at both ends, so the anteroom module can be placed up against a doorway. Then the flaps can be taped down against the wall for an airtight seal. An anteroom can play an important role in protecting a sterile environment, such as a hospital, from construction-related dust and debris. Put in the time it takes to build it properly, and it can save a lot of time and money in the long run. When planning a barrier, whether it will be temporary or long-term, always look for ways to use existing walls as part of the barrier. Can the barrier be put up against an existing wall so that one less side needs to be built? Can the corner of a room be closed off using 2 existing walls? Or can the entire room be used, so you only need to seal off the existing doors and windows, and perhaps add an anteroom? Another option for a short-term barrier is a modular panel system. The most common brand of these panels uses translucent polycarbonate mounted in lightweight aluminum frames. The edges of the frames have gaskets to seal the panels against the floor, ceiling, and each other. The standard width is 48 inches, but panels are also available in 12, 24, and 36-inch widths. The panels extend from about 8 feet tall up to 10 feet tall. The systems include hinged corner posts and door panels with pre-hung gasketed doors that have automatic closers. The panels latch together without tools, and special clips secure their top rails to suspended ceiling grids. Panel sections are also available with a built-in exhaust port to discharge your negative air machine, and with a built-in differential pressure gauge for monitoring negative air pressure. The panels are easy to clean and sanitize for reuse. Modular panel systems are quicker and easier to set up and take down than rigid barriers built with metal studs and drywall. However, a modular panel wall may not be fire resistance rated for long-term use. It's a short-term, temporary barrier. Some hospitals may allow a modular panel system to be used for a project taking longer than one work shift, but will require a fire watch while it's up. To install a modular panel, set it on the floor close to its final position. Loosen the thumb screws on the sliding top panel and extend it up to the ceiling. Next, tighten the thumb screws to hold the sliding top panel in place. Then, secure the top rail of the panel to the ceiling using grid clips. Position the next panel beside the first and join them together with the locking clips. To make a corner with the panels, a hinged corner post is used. Attach the two panels to the corner post using the locking clips. The simplest way to create angles is to first attach the two wall panels to the corner at a 90-degree angle. Then, swing one panel out to the angle you need. Finish the corner installation by sliding the top center post of the corner unit up to the ceiling. The door panel installs the same way as the standard panels. Join it to the adjacent panels with the locking clips. Then, secure it to the ceiling with the grid clips. The gaskets on the edges of the panels should create a tight enough seal for negative air pressure. But if not, you can seal the joints from the inside of the barrier with blue painter's tape. If you need to route the exhaust from your negative air machine out through the modular panel barrier, you can install a panel section with a built-in exhaust port. Whichever methods and materials you use, the goal of setting up barriers is to separate construction activity and construction dust from the other people in the hospital or medical facility. Barriers need to be fire-rated, built correctly, and sealed tight. Taking care to do the job correctly will ensure that the project is completed without causing any discomfort or harm to the patients.